Waals equation and the critical phenomenon. Van der Waals equation for 1 mole of a gas can be written as P plus A by V square into V minus B equals RT. If we expand this equation, we have PV minus PB plus A by V minus AB by V square minus RT equals 0. If you multiply with V square by P, we have let this be equation 1. If you multiply with V square and divide by P, equation 1 becomes V cube minus V square into RT plus B plus V into A by P minus AB by P equals 0. Let this be equation 2. And this is a cubic equation in V, which can be solved for given values of P and T to give 3 values of V. And all the 3 values of V may be real, or 1 may be real and 2 imaginary. And on substituting the values of Van der Waals constants A and B in equation 2, the values of V can be calculated at different pressures for a given temperature. And when the values of V are plotted, P is plotted against V, we get the isotherms at different temperatures. And this is known as Van der Waals isotherm for carbon dioxide. And if we look at the isotherm, at different temperatures, for example, this is the isotherm at 13.1 degrees Celsius. That is, you can see there is a curved portion instead of the horizontal portion obtained in the Andrews experiment. And you can see for a given value of pressure, there are 3 values for V at this particular temperature. Also, if you look at the isotherm at 25 degrees Celsius, this is the isotherm at 25 degrees Celsius, you can again see a wave-like portion, and for a given pressure, there are 3 values for volume. And coming to the isotherm at 31.1 degrees Celsius, that is at the critical temperature, that reduces to a point, and that is the critical state. And at the critical state, we can say there is only one value of V for a given pressure, and that is the critical volume. So at critical state, mathematically, we can write like this. V minus Vc whole cube equals 0. And when this equation is expanded, we get V cube minus 3Vc into V square plus 3Vc square into V minus Vc cube equals 0. And this is a cubic equation. And comparing this equation, let this be equation 3. Comparing this equation with equation 2, and equation 2, when the gas is at critical state, we can replace T by Tc and P by Pc. So equation 2 now turns to the form V cube minus V square into R Tc here there is a P. So RTC by PC plus B plus V into A by PC minus AB by PC, that equals 0. And let this be equation 4. This means equation 2 and 4, they are identical. And if you equate equation 3 and 4 and equating coefficients, we can see here the coefficient of V square in equation 4 is RTC by PC plus B, and the coefficient for V square here it is 3Vc. So we can write 3Vc equals B plus RTC by PC. Okay. And let this be equation 5. Similarly, If you compare the coefficients of V, you can see A by PC equals 3VC square. So 3VC square equals A by PC, and let this be equation 6. And again, if we compare the coefficients, we can say VC cube, that equals AB by PC. This equation 3 and 4 are cubic equations in V, and we are comparing the coefficients. So here this is constant, so AB by PC equals VC cube. Okay, so we have VC cube equals AB by PC, and let this be equation 7. And if you divide equation 7 by 6, we get VC cube divided by 3VC square equals AB by PC divided by A by PC. Okay, so dividing 7 by 6, that is, we get VC cancelling PC, A and VC square, we have 3B equals VC, or critical volume VC equals 3B, where B is the van der Waals constant. And in order to calculate PC, PC, if you substitute the value of VC in equation 6, substituting VC in equation 6, we have 3 into VC is 3B, 3 into 3B square equals A by PC, or we have PC, critical pressure, PC equals A by 27, 9 into 3, 27 B square. So we have critical pressure PC equals A by 27 B square. Okay. And in order to find TC, critical temperature, if you substitute VC and PC, we get, that is 3 into VC is 3B equals B plus R TC by PC value is A by 27 B square. And when this expression is solved, we get, that is 9B square minus B equals RTC by A into 27 B square, or 8B square equals 8 A into B square equals R into TC into 27 B square. Cancelling similar terms, we have TC equals B square is cancelled. So TC equals 8A divided by 27 R B. Sorry, here there is no B square. Here it is only B. Okay. Okay. So 3 into 3, that is 9B. Okay. So here also there is only B. Okay. So we have critical temperature Tc equals 8A divided by 27 Rb. So far we have seen expressions for critical volume, that is critical volume equals 3B, critical pressure equals A by 27B square, and critical temperature equals 8A divided by 27 Rb. So we have derived expression for these critical constants in terms of the van der Waals constants A and B. Okay. Now, what is meant by critical compressibility factor? So we know compressibility factor Z is given by PV by RT, and critical compressibility factor means when the pressure, temperature and volume are expressed in their critical value. So critical compressibility factor ZC equals PC VC divided by RTC. And if you substitute the values, PC, we know PC, that is A by 27 B square, and VC is 3B, that divided by R into TC is 8A divided by 27 RB. And if you substitute the values and on cancelling, we have the critical compressibility factor will be obtained as 0.375. So that is a constant for a